Assalamualaikum and welcome to BFC 15003 calculus. Okay, so in this video, okay, we will learn about differentiation of parametric function. Okay, so in the previous video, okay, we have seen that we can obtain the differential coefficient of implicit function using implicit differentiation. Okay, in some cases, implicit function can be expressed in terms of parameter. Okay, so in this video, we will introduce differentiation of parametric function. Okay, the implicit relationship of x and y can be expressed in a simpler form using third variable known as parameter. Okay, for example, we have a function of x, okay, equal to t square, okay, and y we equal to t power of 3 plus t. Okay, so when we can see here that both function expressed in term of t. Okay, also we can find another function of 3t plus 8 and y equal to t minus 3t. Okay, so these are the example of parametric function. Okay, so the formula, okay, of differentiation of parametric function is, okay, the formula will be dy over dx equal to dy over dt, okay, times with dt over dx. Okay, so basically this is the formula of differentiation of parametric function. Okay, so we can notice that the left hand side and the right hand side are the same if we eliminate the dt terms. Let's see the first example. Okay, so if we are given a function of x equal to 2t and y equal to 4 minus 4t minus 4t square. Okay, so the question asks to find the differentiation, okay, of this parametric function. Okay, so as we know that the formula is dy dx equal to dy dt time with dt dx. Okay, so that means we need to find dy dt and also we need to find dt dx. Okay, so from here we have, okay, x equal to 2t, so therefore dx over dt it is equal to 2. Right, so but here we need to find dt dx. Okay, so therefore dt dx it is equal to 1 over 2. Okay, so now we have y equal to 4 minus 4t minus 4t squared. So dy dt, okay, we will have negative 4 minus 8t. Alright, so now we just substitute, okay, we just substitute everything that we have into the formula. Alright. Okay, so when we substitute, okay, now dy over dx, we just substitute. Okay, so dy dt just now we already obtain negative 4 minus 8t, so times with dt dx, which is 1 over 2, and finally the answer will be a negative 4t minus 2. Okay, right, so let's move to the second example. Okay, okay, if we are given a function of x equal to t minus 3 over t, okay, and y equal to t square plus 4 over t. And then the question asks find dy dt, okay, when, okay, t is equal to 1. Alright, so again, now we have to find dx over dt. So now we have x is equal to t minus 3 over t. Okay, so now we can rearrange. We can make it as t minus 3 and then time with t power of negative 1. Okay, this one we bring it upward. Okay, so we can expand. Okay, when we can expand this one. So we will get 1 minus 3 t power of negative 1. So when we differentiate this one, so dx dt, okay, we will get 3t negative 2, or we just simply write 3 over t squared. Okay, 3 over t squared. Okay, now here same goes with y. We can rearrange. Okay, so t squared plus 4 plus times with t negative 1. Okay, so we just expand. Now we get t plus 4 power t negative 1. So dy dt, okay, we just differentiate, we get 1 and then negative 4 t power of negative 2. Okay, or we can write 1 minus 4 divided by t squared. Okay, so now we can insert everything into the formula. Okay, now you see, notice here, we already found dx dt. So what is dt dx? So dt dx, we will get t squared over 3. So we just substitute this one, dy dt and also dt dx into the formula. Okay, so when we substitute, okay, dy dx, it is equal to dy dt. Just now we get 1 minus 4 over t square and multiplied with a dt dx, t square divided by 3. Okay, so and finally we will get the answer is 1 over 3 t squared minus 4. Okay, so the question asks find dy over dx when t is equal to 1. Okay, now we just substitute a t with 1. Okay, so we will get 1 over 3, 1 squared minus 4. Okay, finally the answer we get is negative 1. Okay, let's see the third example. Okay, so if we are given a function of x equal to 5 cos t power of 3 and also we are given y equal to 7 sin t power of 3 also. Okay, how can we solve this one? Okay, so the first one we need to find dx dt. So dx dt. Okay, so we can solve this one by using chain rule, right? So by using chain rule. Okay, so now we can differentiate. Okay, maybe we can just put 5 outside. Okay, so now we just differentiate cos t cube. So we get 3, okay, in bracket cos t square. And then we need to differentiate cos t. Okay, so differentiate cos t, we will get negative sin t. Right? So now we just expand. Now we will get negative 15 cos square t and sin t. Okay, sin t. So this one adalah dx dt. Okay, so therefore dt over dx, okay, will be 1 over negative 5 cos square t sin t. Right? Okay, now boom, we already find dt dx. So we have to find this one, okay, dy dt. So what is dy dt? Okay, let's move to another page. So I'll just write back y equal to 7 sine t cube. Okay, so now dy dt will be 7, okay, 3 sine t square, and then we need to differentiate inside, okay, the sine t, we will get cos t. Okay, so finally dy dt it is equal to 21 sine square t cos t. Okay, so now we already find the dy dt. Alright, the formula, okay, as we know, the formula is dy over ds equal to dy dt times dt dx. Okay, we know that our dy dt is 21 sine square t cos t. So we just write back 21 sine square t cos t. Okay, multiply with dt dx. Okay, our dt dx is here 1 over negative 15 cos square t sine t. We just put here 1 over negative 15 cos square t sine t. Okay, so here cancel off here cos t, okay, cos t with another one here, and sine t with here. Okay, so now what left is we have 21, okay, 21 sine t divided by negative 15 cos t. Okay, so we know that sine t over cos t is equal to tangent t. Okay, tangent t. And also this one, we can simplify, divide by 3, we will get 7. And divide by 3, we will get 5. So the answer will be negative 7 over 5 tangent t. Alright? Okay, that's all. We will continue the next subtopic in another video. Thank you.